Yes, sir.
Okay, great.
Yes, sir.
I will need to also stop my video so that we can have the best of experience. Now, good evening once again, my beloved student, and I believe you are enjoying your day. I want to sincerely believe you are enjoying your day. Welcome once again to this course, Digital Logic Design or Digital Computer Design, depending on where you belong out of the two category. Today we shall be looking at a very interesting topic, and I want to crave your indulgence that you pay very close attention to what we'll be doing today. Please pay a very close attention. I will try to be as patient as possible, and I will try to be as explicit as
Sacrifice
possible.
the earpiece for me. I mean, I want to attend class. Sacrifice the earpiece for me.
Divine, you are distracting us, please. Okay? Divine, you are distracting us, please. Okay, so I said I will be as explicit as possible to ensure you have a very massive experience and then get a better understanding of what we'll be discussing this evening. So I have the following learning outcome to achieve today, and I hope sincerely we'll be able to achieve all of them. Yes, they are lofty ones that at the end of this class today, it is the expectation that you should be able or that you will be able to analyze and simplify Boolean expression using Karnaugh Maps to minimize logic gates. That is one of the key ones we intend to achieve. And every other one might just be connected to that very first learning outcome that we have set before ourselves today. Okay. Number two is to be able to interpret, minimize Boolean expression to create optimized logic circuit. Definitely, I'm also sincerely trusting that we will be able to also achieve that earnestly today, for you to be able to come up with a circuit at the end of minimization of your Boolean expression. So we'll be able to also achieve that, all things being equal. Also, you should be able to explain the principles and operation of fundamental combinational circuits, including adders, multiplexers, and comparators. Time, I wouldn't know, but that is part of the objective we have ahead of us. Then you should be able to design and implement half adders, full adders for binary arithmetic operations. You should be able to construct multiplexers to perform data selection and routing in a digital system. And lastly, you should be able to design and test comparator circuits for magnitude comparison between binary numbers. So those are the intended learning outcome, and I want you to pay close attention as we go on. Remember, in our previous class, we have looked at, or previous classes, we had a look at binary number system, and we have also looked at Boolean algebra, we have looked at the Morgan theorem, and we have looked at how we can actually apply some of those principles to minimize Boolean expression, okay? So today we want to look at what role can Karnaugh Map achieve in us handling simplification of Boolean expression. How do we go about it? And it's very important we'll be able to deliver that even at the end of this class today. But before we go into the details of that, I would like to say that when we talk about Boolean algebra, we have been talking about this definitely. We are talking about a concept that is deeply rooted in designing efficient and effective digital logical circuits. Okay? So when we talk about Boolean algebra, we're talking about the mathematics behind designing efficient and effective digital circuits. Okay? So you don't just come up and begin to buy gates and then they begin to put them together and say, yes, I've designed a circuit. No, there is the need for you to be able to design a digital circuit in an optimized manner, in such a way that you minimize the costs, and then you also have a simplified, a more efficient system. I give you a typical instance. If you have to pass, for instance, you have to pass a liquid from a bottle of water, maybe to, you have to pass a bottle of water, a bottle of your canned water now. You need to empty the contents into a cup. I believe that can be very fast and efficient, isn't it? However, if you are to empty the same content this time around to the same cup, but this time around, you need to pass the content through 5 other bottles, okay? You will all agree with me that definitely the latter process cannot be as effective as you just passing the water from the bottle directly to the cup, okay? Definitely passing it from the bottle directly to the cup will be more efficient, will be more effective, and will save time, will save cost. Compared to if you have to take the water from the main bottle, empty it to another bottle, then take it from the second bottle to a third bottle, and take it to the fourth bottle, and on before you get to the final destination where you want it in the cup. And those two simple illustrations I've just given you are just like designing a digital circuit with minimal number of logic gates compared to designing it with several logic gates that are not necessarily important in the system. And so Boolean algebra, Karnaugh map minimization, De Morgan's rule, all these come together to help us to simplify the circuit so that at the end of the day, the digital circuit we have will be a simplified version that will be very efficient and very effective, okay? And so the simplification process helps to reduce the number of logic gates that will be required. Thereby, you are cutting costs in designing your logic circuit. It will also, in a way, make your circuit to be faster. It will also make it to be less prone to error, like my illustration, passing the content of a bottled water, the water, to another to a cup. Of course, there will be lesser error, lesser issue. There will be lesser spill of water if you pass it directly to the cup. Unlike taking it from the second bottle to the third bottle, in the course of pouring into those bottles, you can be sure some of the water might actually be thrown away, which is not what is expected. And that can also be looked at in the perspective of digital circuits. So you may end up having a situation whereby you will have the content or the circuit to be having series of error when you're trying to implement the circuits. And so by so doing, you won't have an effective system that you're working with. The next is when we are simplifying the Boolean expression, what comes to mind are those basic rules that we have talked about, like the De Morgan's rule, and then a Karnaugh map also come at the center, especially when you have a complex Boolean expression to actually minimize, okay? Now, what are the objectives of this minimization? I've talked about them extensively. Number one is to minimize logic expressions for efficient circuit implementation. Number two is to reduce hardware requirements and cost, okay? So if you are cutting the number of hardware that you need, in place of using 20 AND gates, you now end up using just 2 AND gates. Of course, you have reduced the number of hardware that you'll be using, and you have also what? You have also reduced the cost associated with it, okay? It also helps us to improve the speed of digital system by optimizing what? The logic gate usage. So it brings about optimization, it brings about cost cutting, and it brings about what? Efficiency in circuit implementation. So please take note of that. It's quite very important. Now, in simplification, we have the algebraic means of simplification, which we did extensively in our previous class. For those of you that attended, I believe you can actually I give credence to that we have actually done an extensive work along that line. Okay. Now, again, we can also make use of the De Morgan's theorem. We also look at that one in our previous class. Okay. And so today we want to look at a graphical approach for simplifying this expression. And that is what? The Karnaugh map. Okay. So when we talk about the Karnaugh map, what are we actually talking about? We're talking about a graphical tool for simplifying what? For simplifying Boolean expression. Karnaugh map is used for what? It's used to simplify Boolean expression by what? By using graphical approach. And we are delving into that very, very quickly now. What is Karnaugh map? What is Karnaugh map, or simply referred to as K-map? K-map. When I say K-map, I'm talking of Karnaugh map. Okay. So what is Karnaugh map? Like I said earlier, it's a graphical method that is used to simplify Boolean expression. And what does it do? How does it achieve that? It achieves the simplification by visually grouping together combinations of input variables that produces the same output. So Karnaugh map is a graphical method of simplifying Boolean expression. And how does it do the simplification? It does that by what? By visually grouping together various combinations of inputs variable that produces the same output. So if you have different variables that produce the same output, then you group them together, okay? And by doing this, you will be able to identify the patterns and be able to come up with what? A minimized logic circuit design. Okay? Like we said, it's visual representation of the truth table, and it helps in simplifying the Boolean function without going through the rigors of the complex algebra we were doing the other time. Okay? It helps us to simplify the expression by what? By using graphical approach, and then we don't have to go through the complex mathematical algebraic manipulation like we did in the previous class. Okay? Now, there are important terms that you need to pay attention to when we're talking about Karnaugh map, and I'm just going to define them very quickly as we can see on the screen. The first term is what is referred to as minterms. Minterms, M-I-N-T-E-R-M-S, minterms, okay? What is minterms in Karnaugh map? It refers to a product term that includes all input variables in either true or complemented form. Meantime is a product term that includes all input variables in either true or complemented form. Okay, I believe you know what we mean by complemented form. Okay, for instance, we can say A is equal to 1. Okay, then if A is equal to 1, what will be the complement of A? The complement of A will be what? Will be 0. Okay, that is A prime, which is the complement of A, will be what? 0. Okay, then we have what is known as the maxterm, M-A-X-T-E-R-M-S, maxterms. What is maxterm? It's talking about the sum term that include all input variables in either true or also complemented form. Okay, why meantime is the product term? The maxterm is what? Is the sum term. Okay, please take note of that. The meantime is the product term. Why the maxterm is the what? Is the sum term. When we talk about the adjacent cells, cells in a K-map that differ by only 1 bit. You know what bit is? Bit is talking about the binary digits, okay? So when we talk about adjacent cells, we talk about cells that differ by only 1 bit. You will see that very quickly and very shortly. Adjacent cells, okay? adjacent, talking about next. And the adjacent cell, in this case, we're talking about there is a difference of just 1 bit, okay? For instance, if I have 0, 0, if I'm dealing with maybe a 2-input gate, and I have 0, 0, is that okay? The next adjacent cell cannot be 1, 1, because by so doing, there will definitely be a change of 2 bits, not 1 bit, okay? So the next adjacent cell to 0, 0 can either be what? 1, 0 or 0, 1. That is, only 1 bit will change per time. Okay? Now, let's look at the steps. Please pay attention here very critically. Let's look at the steps that we need to follow to be able to construct K-map. Please pay attention very critically here. I see a very few of you online. That's okay. Now, the first thing is that you need to define the number of variables. There must be a definition of the number of variables involved in the K-map you are about to construct. Okay? Remember, in the previous class, we had established that if you have any number of inputs, the formula to use to determine the possible likely outcome is 2 raised to power n. 2 raised to power n. I believe you can remember that. 2 raised to power n, as you can see here, okay? So we have 2 raised to power n as a formula that can give us the likely number of variables we can be dealing with, okay? For instance, if I'm dealing with, say, for instance, a 2-input case study, okay? So my K-map that I want to construct will be 2 raised to power 2. And by implication, that will give me 4. 2 raised to power 2 is 2 times 2, and it's giving me 4. So meaning for a 2-input K-map, I will have 4 cells, okay? If I have 3 inputs, I will have 2 raised to power 3. 2 raised to power 3 will be 2 times 2 times 2. 2 times 2 is 4, times 2 again is 8. So for a 3-input variable, I'm going to have what? 8 cells, Karnaugh map, okay? If you go to 4 inputs variable, for instance, we have 2 raised to power 4. That will be 2 multiplied by 2 multiplied by 2 multiplied by 2. And that invariably will give us what? We give us 16. So if you are dealing with 4 input variable, meaning you will have 16 cells K-map. So you should be able to determine the number of variables and apply this simple formula to know the number of cells you're going to have in your K-map. Having done that, the next is that you should be able to create the K-map grid. Okay? Now, let's take it for instance. For instance, we have a 2-input K-map here, 2-input K-map. 2-input K-map. We have A and B. They are just 2 inputs we are dealing with. And because we have 2 inputs, which is A and B, 2 raised to power 2 will give us 4. And so here we have 4 cells. This is cell 1, cell 2, cell 3, cell 4. Representing what? Representing the K-map for 2 input variables. Okay? Now, here we have on this A, this is A. We are using this horizontal line to represent our A, while the vertical line is representing what? Our B, okay? Horizontal line representing A, and then a vertical line represent B, okay? A, if A is 0, A can also be 1 here. So we have 0, 1. Here we also have what? 0, 1. That's the best you can have here, okay? Now, look at it. A and B are present in each of these cells, okay? A and B are present there. But in this case, look at what we have here. I have A bar, B bar, that is A complement, B complement. Why is it A bar, B bar? Because if you look at what we have up here, 0, meaning what? Is the complement of A I have here, why I have the actual A here. Okay? Is the complement of B I have here, I have what? B here. So by implication, this whole cell will become what? A bar, B bar. Okay? Coming here again, what are we going to have here? I'm going to have A. It's 1 here. So I'm going to have A. And here, tracing this one here, I'm having what? I'm having B bar. Okay? Or B complement. Then coming here again, trace this one here. This is A bar. And here I have what? I have B. The same thing here, tracing these two. You have A, B. That is what we have here. Then if you go ahead and also look at having the 3 inputs, okay? So we said AB on the horizontal line, and we have C here, okay? Now take note of this. On the AB, we have here, we said we have 0, 0. Remember, we said in K-map, there is need for you to ensure only 1 bit changes in the adjacent cell. That is the definition I gave you earlier. Okay, so if I'm moving 0, 0, the next one is 0, 1, only 1 bit change at a time. Okay, I cannot go to what? 1, 0 here, because if I go to 1, if I choose this third column to be 1, 0, I would have changed these 2 bits here, and that is not permitted in the Karnaugh map. And so for us to maintain consistency of ensuring that for adjacent cell is only 1 bit that changes. So this one is 1, 1. Please take note of it and don't make mistake whenever you are dealing with Karnaugh map. Okay? So you have 0, 1, 1, 1, and then you have 1, 0. Okay? So please take note of that. So I repeat, you have 0, 0. 1 bit changes at a time in the adjacent cell. We have 0, 1. Okay? Meaning 0 has changed to 1 here. Okay? Then coming here, this one also changes. That's why we have 1, 1. And changing again, this last one changes to 0. Then we have 1, 0. And this one still maintained is 0, 1. So if we are looking at the content of the Karnaugh map here again, that we're using to represent what we're doing, we have 0, 0. That is A bar, B bar. Then 0, C, C bar. Okay? We have 0, 1. That is A bar, B, then C bar on this row. If you check the whole of this row, or C will be C bar because it's 0 you have, or true. Check the whole of this one, or true. You will discover that all C will be C. Is that okay? That is what, because you have 1 here. Coming to check this one, if you check the whole of this row down, AB will be AB bar or true. Okay, and that is what you have in these 2 cases. Here also you have 0, 1. Your 0, 1 here, meaning A bar B. A bar B, that's what you have here. You have A bar B also here. Coming here, you have 1, 1. That is AB. You have AB here. You also have AB here. Then coming here also, you have 1, 0. That is AB bar. You can see it here. You can see it here. I believe that is understood by everybody. We can also look at having 4 inputs. You have AB on the horizontal, and also on the vertical, you have what? You have CD, okay? And what I explained earlier, adjacent cell, only 1 bit can change. So you have 0, 0 to 0, 1 to 1, 1 to 1, 0. Please take note of it. And like I said, if you look at this 0, 0 meaning A bar, B bar, that is what you have maintained all through here, okay? Check this one. This is A bar, B. That is what is maintained across all this. Check. This is 1, 1. That is AB, maintained all through here. Check what is maintained here, 1, 0. That is A, B bar. That is what is also maintained down this row. Coming here also, you have 0, 0, which is CD, C bar, D bar. That is what we maintain in this row all through. The same thing here. This will be C bar, D. And that is what you are C bar, D, C bar, D, C bar, D, C bar, D. Then this one will be CD, 1, 1. And you have it all through. And lastly, here you have what? 1, 0. That is C, D bar, is what you also have all through. So combining all of them, you can see in this 4 cell now, because we have 0, 0 here, 0, 0 here, we have A bar, B bar, C bar, D bar. You can check each and every one of them and see what it is. You can also have 5 input variable and so on and so forth, depending on the number of input you're dealing with. Now, having done that, the next thing is to use the gray code to now label the rows and column of the K-map. Okay. Now, what is gray code? Gray code ensures that only one bit changes between the adjacent cells, which is critical for grouping terms. I've explained that in detail. Okay. So example is that you can only move from 0 to 1 and 1 to 0. Then you can only move from 0, 0 to 0, 1 to 1, 1 and to 1, 0. And then on the column, the same thing here. And here for 4 input variable, you have 0, 0, 0, 1, 1, 1, and then 1, 0. That I've explained extensively. Okay. Then there's need for you to now plot the mean terms. The mean term, which is the product. Okay. Mean term is what you plot in the K-map, not the max term. Max term is the sum. Mean term is the product that we plot in the graph. Okay. Now, there's need for you to convert the Boolean expression into mean terms. Okay. That is the terms where the function equals 1. Okay. The term where the function equals what? 1. Each mean term corresponds to a unique binary combination of the variable. And they're saying for you to now locate the cell in the K-map that matches the binary combination. And then you will place a 1 in that cell. Okay. You will place a 1 in that cell. Let me just quickly go back one time. You know, if you look at this, for instance, if you have a function, let's use this simple one so that you will have a better picture of what I'm trying to say. I'm trying to activate a pen. Okay. So let's assume I have a function that I define as this. I said f is equal to, and I said a, b, okay, plus, then I said a, b plus a bar, b. Okay, so that's a function. If I want to now plot this function in this 2 input K-map, where will I put 1? You can unmute yourself and speak. Let's make this one interactive a bit before we go further. Unmute yourself and speak so that let me be sure I'm not speaking to myself only. Yeah. So where am I going to put 1 now? Remember, he said the mean term is what we are plotting now. This is the function I want to minimize. Okay. So what will I do? Where will I put 1 now? Yes, I'm listening. Unmute yourself and speak. I'm not hearing anyone. You raise up your hand if you want to speak, and if you're not speaking, I will be calling you by name now. So let me even be sure of those who are in class. Okay, Gideon. Gideon, unmute yourself and speak. Speak to my explanation. Okay, Gideon is absent in class.
Come again with, please come again with the question, sir.
Gideon is the one I'm even asking to speak. Gideon, speak. Let me hear you that you are even in this class. So meaning Gideon is not in class. He only connected the phone and walked away. So it will be noted like that in the attendance as well. Gideon, are you there? You want to unmute yourself and speak now? Let me be sure you are there. I'll just speak your name. Okay, it's not there. Now, my question is this. Are you with me, everyone? My question is this. This is a function that we want to minimize. F is equal to AB plus A bar B. Okay? So, this is the function that we want to plot. So I'm saying in this 2 by 2 Karnaugh map, where am I supposed to put this, my function in this place? Okay? Where am I supposed to put? Am I putting anything here? Are you seeing my mouse? Okay, the first cell, am I putting anything there? Yes or no?
Yes.
Yes.
What is yes? Do I, in the function that I have, do I have A bar, B bar in the function? Do I? Do I have anything like
Yes,
A bar,
sir.
B bar
Yes,
in
sir.
this function? Do I
Yes,
have
sir.
it?
No, sir.
No, sir. So there will be nothing in this first cell.
At all. There is no A bar, B bar in the function.
Yes. Then do I have A, B bar? Do I have anything there?
Yes, yes, sir.
I don't have it. So
On that,
do I have
that
A
one.
bar, B? So meaning I will put 1 here. Okay?
One.
We'll put 1 here. Okay? This A bar, B bar, this A bar, B will not be there when you are doing your mapping. This is just for illustration purpose. Then I have A, B.
Okay, sir.
I also have this one here. Okay? So I'm done representing this function in a Karnaugh map. Then the next thing I need to do is to now map it and circle it this way. Okay? And after circling it now, what will be my function now? The minimized function. Somebody try to, someone try? What will be my minimized function? Yes, can you try? See what I've mapped. Now, what I've cycled now,
Yes,
what is common to that
Alright,
place? What is
yes.
common to that place now? Because we are trying to minimize it. Eh? What is common?
A.
Eh?
A is common, sir.
B.
What is
A and
common?
B. A and B is common, sir. Abi?
No.
It's B. B is common.
B is common, sir.
Thank you.
Yeah,
So
B is
the,
common.
the minimized function here is what? Is B. So
Okay,
with just
sir.
a
Wait,
simple,
excuse me. Come on,
yes.
bro. Now, but you come here. If I met you, I come here. What
Who
level?
is distracting us again?
It
Divine.
doesn't matter.
Who is
It matters.
distracting us?
It's only 100 level and 200 school said we should do for. So it matters.
Divine.
The rest levels are good.
Who are you speaking with? You are distracting us now. Is there any issue you want me to listen to? Divine.
Sorry, sir. I forgot to mute the mic. Sorry, sir.
So I don't
It's all
understand
right.
anything.
Yes. Which of them you don't understand? Can you speak up?
From the second diagram.
Now, look at what we've done here. Let me activate the pointer now.
Okay.
This is the function. Can I change this pointer? Okay. Now, look at what we have here. Sorry, I'm trying to activate my pointer back. Now, look at what we have here. This is the function you want to minimize. Okay? In trying to minimize this function, we need to plot the Karnaugh map. It's 2 inputs. It's just A and B that are our inputs. And we already know the format of 2 input Karnaugh map. Okay? And we need to begin to fix the mean term into the map. Okay? In the function, do we have A bar, B bar? The answer is no. So there won't be anything there. In the function, do we have A, B bar? The answer is no. Nothing will be there. In the function, do we have A bar B? The answer is yes. Put 1 here. Okay. In the function, do we have AB? The answer is yes. And we have 1 and 1 here as our mean term that has been plotted into this map. Then you cycle it, what you have plotted. Okay. That's a mapping. Map it. Okay. You can map adjacent. You can map side by side. You can map either diagonally or you can map diagonal. You can map either horizontally or vertically. Okay. So I've done horizontal mapping now. Okay. Now, after mapping it, I need to just pick what is common to what I've mapped. Okay. So I'm now asking, what is common to this thing that I've mapped here? Is it B or B bar or A or A bar or A B bar? Which one is common to this that I've mapped?
B.
B. Because we are in the column where we have 1 in the column of B. Okay. So meaning B is what is common. So my minimized function is what? B. Simple.
B.
That's how Karnaugh map work.
Oh, sir, how do we mark
Yes.
horizontally?
How did I do what?
How do we mark horizontally?
If I have 1 in this place, then I can also map across this place.
Okay, sir.
Okay. So
Yes,
but
sir.
just what I have is 1, 1 beside each other. So it's only horizontal mapping I can do this way. You will see other type of mapping as we go.
But sir,
Okay.
sir,
Yes, go ahead.
yeah, I don't understand though.
See, tell me what you don't understand, which part you don't understand.
In the horizontal mapping and the this thing.
Now, look at it. But you understand how we put 1 here and we put another 1 here.
Yes, sir.
Good. Then the mapping is this one. We are mapping them together. We are putting a cycle around them. That's the mapping. Okay?
Yes, sir.
And the way I've mapped it now, is it horizontal or vertical? Horizontal mapping, that's what I've done.
Yes,
and I
sir.
said, let's assume maybe in our function, we had gotten maybe A bar, B bar, and we put 1 here also. Are you following me? Meaning I will also map this. Are you getting me now? Or better still, let me increase this function further. You understand it now? I'm increasing
Yes,
that
sir.
function. Let's say we now have in this place now. I'm not seeing my pointer now. Let me see. Let me change my ink color to okay, blue now. Okay, but I'm not saying it too. Okay, see where it is now. Okay, I come up here now. I now have plus. So this is an additional 1. No, plus what? Plus A bar B bar. Are you following me, everybody? So I now have this function as, instead of what we had earlier, we now have a function f is equal to AB plus A bar B plus A bar B bar. Okay, so meaning I'm going to have additional 1 in this place. Are you with me, everybody? Then
Yes, sir.
I will also need to do the mapping like this. Okay, so if I now do this mapping like this now, meaning I've already gotten my B earlier, then I will now have plus what is now peculiar to this second mapping we have done now.
B bar.
B,
A bar.
are you sure?
A bar.
A bar. So then we're going to have A bar. I believe that should have explained it better now to everybody.
Yes, sir.
Yes, sir.
Good. So let's just go on and look at the next one. So I think we've been able to take care of all this. So I think, okay, plot in mean term, convert the Boolean, leave the remaining cell as 0. So that's all we have just done practically now. So let's now look at an example. Now, if you look at what I have on the screen, how many inputs do I have there?
5.
No.
3.
How many Boolean inputs?
Oh.
How many?
3.
3.
3. ABC.
3. Thank you. A, B, C, 3. It's not 4, it's not 5.
Okay,
we have F is equal to, sorry, we have function that is defined as F. We define a function F consisting of what? Input A, B, and C. And we said that function is equal to what? The summation of what? Summation of
0, 4, 5,
set of numbers.
4, 5, and 6.
And 6.
Now, these numbers you are seeing here are simply representing what? The decimal numbers. Okay? And when we were dealing with number system, I believe you know what 0 represents if you are dealing with 3 bits. You know what to represent when you are dealing with 3 bits, and so and on and on and on. Are we together? And so let's look at the step-by-step of solving this problem. So coming here, this is the decimal number. Let me activate my pointer again. Don't use pen. Those of you writing on the screen, you should be writing in your own notes now. Is that okay? That's what you need now. Now look at it. This is A, B, C. That's the input. Okay? 0 in decimal is what? 0, 0, 0. Is that okay, everybody?
Yes, sir.
And 2. 2 is what? 0,
0, 1, 0.
0. I believe that is understood by everybody.
Yes, sir.
Then we have 4. 4 is what? 1,
1,
0,
0, 0.
0, 0. Then you have 5. 1,
0, 1.
0, 1. And then we have what again?
6.
6, which is what?
0.
1, 1, 1, 0.
1,
Okay.
0.
Now, do you also know that we can write out this function? Let me quickly do this. Hello, please, no distraction, please, please, please. Now, let's do something here. You know, this one simply represents what? This is simply what? A bar. Are we together?
Yes, sir.
Yes, sir.
A bar.
Yes, sir.
And what? Please, those who are distracting the class, please mute yourself. Or better still, you can disconnect. Is that okay? Now, for those of you that are distracted, don't push me to a level whereby I will remove you from the class, please. If you are not ready to listen, don't distract others who are willing to listen and learn. Please, I'm pleading with you. Is that understood, everybody? If you must speak, then you should mute yourself and do whatever you want to do, so that you'll be distracting the class. Okay? So, for the first decimal given, which is 0, we can write it as this. Is that okay by everybody?
Yes, sir.
Okay. What will this second one be? What will it be?
A bar, B, then C bar.
Good. So we can write that function as what? Plus. So we can say that our f, as given earlier, is equal to A bar, B bar, C bar, plus this one is what? A bar,
B, then C bar.
B, then a C bar. Okay? Then you have plus, and then you continue on and on until you pick the last one. You can see how you can transform a function given in this format, how you can translate it to this type of format I have here. Is that understood by everybody?
Yes, sir.
Yes, sir. Yes, sir.
Good, good. So let's go to the next stage. Now, having done that, then we need to create our Karnaugh map. Now, we have 3 inputs, meaning we need how many? 2 raised to the power 3. That gives us what? 8.
3.
Okay? That gives us what?
8.
8. And look at it. That's what we have down here.
Yes, sir.
Yes, you can speak. I'm with you.
I have a question. Can you go back, please?
Okay.
Okay, so anywhere we have 1, it won't have like the variable won't have a bar at the top.
Complement.
Yes.
Okay.
Is that understood?
Yes, sir. Thank you very much.
Okay. Now, this is where we are now. On this horizontal axis, we have AB. Don't mind my diagram here. It's not like what we have earlier. Please just know that this AB is referring to this place. Okay? Meaning this first digit represents A, the second digit represents B. Okay? Then C, referring to this one that you have along this column. Is that okay, everybody?
Yes, sir.
Good. Now, looking at the function that we have, okay? The very first one we have is what? A bar, B bar, C bar. Where will it be in this place? Let's begin to do it by ourselves now. Where will it be? Where will it be?
Also, so yeah, this thing don't take complicated.
Look at it. The first one, I'm going back here. Look at it. This very first one. Are you following me? This A bar, B bar, C bar, isn't it? Put together.
Yes, sir.
So coming to these cells now.
Yes, sir.
What is A bar, B bar, C bar? Is it this one? Is it this one? Is it this one? So where will be A bar, B bar, C bar?
The first one.
Because this is 0,
The
0.
first one at the top.
0. So meaning this is where we will have our 1 to start with. Okay? And let's look at the next one. Say go back. So the next one is we have A bar B, then C bar. A bar B, then C bar. So it's just like saying you have 0, 1, 0, right? 0, 1, 0. Look at the number here too. 0, 1, 0. Okay? So this is 0, 1, and what? 0. So meaning all we've got here, let me pick pointer and then I point those ones. So meaning we've gotten 1 here. We have also gotten 1 here. Are we together? Then let's look at the next one. Ready? So the next one, 1, 0, 0, right?
Yes,
1, 0, 0. Can we go there?
0.
Where will it be? AB is 1, 0, and then what? 0. Are we together, everybody?
Yes, sir.
And the next one is what? 1, 0,
1, 0, 1.
So 1, 0, then we have 1 here. Okay?
1. Yes,
and
sir.
then lastly, what do we have again? We have 1, 1.
1, 1, 0.
So lastly, we have 1,
1, 1,
0.
0, 0. Up. The last one down, up.
1, 1. Where is it going? 0. Right?
There. Yes. Yes, sir.
And so, how do I map? Can somebody suggest how best to map this? How best to map this?
Horizontal.
Yes?
Horizontally.
Horizontal. How many am I going to map horizontally now?
4.
That's
The 4.
4.
Thank you.
4 by 4.
So 4. I'm going to map that one first. Let me choose another color. So I'm going to map this. Okay? Good. Then what can we map again?
The vertical one.
The
So
vertical.
the vertical one. So we also go ahead and also map this.
1, 1.
Okay? Now, so
Yes,
what
sir.
is our function now? Let's
Sorry,
now.
sir. I don't understand.
Yes, which parts you don't understand? Can you quickly?
I don't understand how you are putting the 1. No, no.
You don't understand how we are putting 1.
Yes.
Come here first. Do you understand how we got this table?
This table. Yes.
Do you understand how we got this table?
No.
Did you say no?
Yes, sir.
And if you are saying no, that means you were not with us. And we can't be following, we can't be working with such people who are not following us. Because we have explained that table over and over again. So if you have to wait for somebody like you I think we won't move forward. Because I've explained this more than twice. Everybody said they understood. So how come you're saying you don't understand this one now? If I may ask you, do you understand this question? Do you understand this question at all?
Yes.
How many inputs do we have here?
3.
3 inputs. Okay. And this number, what do they represent? They represent decimal. Okay? And the decimal values are here. I'm taking my time to explain one more time. These are the decimal numbers, okay, which is given as your function. And you have 3 inputs, A, B, C. So 0 in decimal is 0, 0, 0. Okay? 2 in decimal. If you want to convert 2 to decimal, it will give you 0, 1, 0. This was one of the first tables I gave you during the first class I had with you physically. Okay? And if you don't, you should be able to convert 2 to binary now. Keep dividing it by 2 and keep picking the remainder. You will end up with 1, 0. Okay? And then because it's 3 bits we are dealing with, you have to retain 0 at the back. If you convert 4 to binary number, you end up with 1, 0, 0. If you convert 5 to binary, you end up with 1, 0, 1. Convert 6 to binary, you get 1, 1, 0. Is that okay? Is that okay, young man? Okay. Now, I'm not saying the function that is given as this can actually be written by using the input as well. Okay? Then we can write the same function f is equal to what? Because this is 0, 0, 0, meaning this is A bar, B bar, C bar. So meaning this first one represents A bar, B bar, C bar. Then plus the next one. This is A bar, B, C. Is that okay? I wrote the second one. Then plus the third one will be what? A, B bar, C bar. The next one will be plus A, B bar, C. Plus the last one, A, B, C bar. So that will be the function represented this way. And I'm saying from either this or from this number, you can then fill in this Karnaugh map. Okay? Now for this Karnaugh map that you have here now, we already define our AB as this row, which is 0, 0, 0, 1, 1, 1, 1, 0. Okay? And we have 0, 1 here, representing the C. Okay? And then if you pick the first one, for instance, you have 0, 0, 0, which means you have A bar, B bar, C bar. And it represents this first one. That's why we put 1 here. And we pick the next one, which is what? A bar, B, C bar. This is C bar. And it represents this, okay? So we put 1 here. Going for the next one, which is 4. 4 is 1, 0, 0, okay? And we have 1, 0 here. This is also another 0. So we come here, we put 1 here. Okay? The next one is 5, which is 1, 0, 1. Okay? 1, 0, 1. This is 1, 0. And then you come here, you put 1 here. And lastly, you have 6, which is what? 1, 1, 0. Okay? 1, 1, 0. So we have 1, 1 here, and we bring 0 here. And so that is how we are able to get all these ones into these cells. Do you understand now how we're able to put all these ones here?
Yes, sir. Thank you, sir.
Now, the mapping we cycle all these horizontal. I said the mapping can either be horizontal or vertical. Is that okay? As long as they are adjacent to each other. So meaning these 4, they are connected together, so we can map them together. So we have the whole of that one as our first one. And then the second one, we also map these 2 together. It doesn't matter that you have mapped it before, you can also map it again. Okay? So we have this map 1, we have this map 2. So maybe I should use a different color so that let's do it together. I want to change the color again. Let me change this one to red. So let's take this one as our red map. Okay? So let's work with the red map first. What does it stand for? The red map, what does it stand for? What is common in the red mapping?
1.
Yeah? What is common in the red mapping?
1.
1.
We're not talking about 1. Now, is it A, B bar,
Okay.
C, or
Okay.
C bar, or whatever?
Okay.
Eh?
A bar C.
Come again.
A bar C.
That's not correct. You know why C is not it? Because
Okay.
look at it, oh. Why C is out of it? So that let me explain why it is not so. Look at it. It cannot be C because this one is C, this one is C bar. Okay?
Oh.
You understand?
Okay, it's B
Look
bar.
at it. This
Yes,
is
sir.
C bar. This is what? This is C. So it couldn't have been a C bar. Okay? So what do you think it is?
B bar.
Just B bar alone?
A, then B bar.
A, B bar. Is there anybody that is supporting that?
A. Yes.
Is there anybody that is not sure? Oh, sorry. Need
A
to clear this.
and B bar.
Yes. Is it clear to everybody? So
Yes, sir.
A,
Yes, sir.
B bar.
B bar. But we are not done. Plus what?
For the horizontal now.
Yes.
A bar.
So what is there?
A bar.
C bar.
C bar.
C what?
C bar.
Perfect. Is that understood by everybody?
Yes, sir.
Who is saying no, sir? Look at that. Look at it. It's only C bar that is common to the whole of everything you have in that. So, is that okay? So if you look
Yes, sir.
at the first two columns, yes, you have A bar there. Understand? But if you look at the third and the fourth column, A bar is not there again. So it's only C bar that is common to all those four. And that is why we have C bar. Is that understood by everybody?
Yes, sir.
Okay. Now, that is the perfect thing you have done. The next thing is for you to now draw the circuit diagram. Okay? Simple. Just make sure you know different type of gate like I taught you in the last class. So, how many gates do I need now? First, I need the first gate, which is an AND gate. Are you following me, everyone?
Yes,
I have
sir.
a 2 input AND gates, okay? Now, in this, my 2 input AND gates, I have my A. A is the one that is coming in here. Are we together, everyone?
Yes, sir.
But I need an inverter here. So, meaning I need a NOT gate here. The diagram may not be perfect, but I believe you can get the concept we are trying to do. So I have B here. Are we together, everyone?
Yes, sir.
So this is B that is coming in here. This inverter will change it here, and it will become what? B bar at this point. Okay?
B bar.
And so this one will come out. Then the next one is what? C bar. So we can also see C is coming here, but definitely it will also go through an inverter that will invert it. Okay? Then the two of them are now going to where? They are going to join an OR gate. And finally, this is our F function. Is that okay, everybody?
Yes, sir.
Simple?
I'm lost
Okay.
already, sir.
So,
Good. So that's just the procedure. It's simple. Okay. Now, with what we have done here now, we have implemented the circuit, we have minimized it. Compared to look at number of gates, so we just use 2 gates, just one AND gate, and then one OR gates. Okay. All these ones are just inverters, so they are not really considered as a gate as such. Okay. So we just use 2 main gates to implement the circuit. Compared to if we had implemented this way, we need 3 inputs and gates. Look at it all. Okay, maybe I should implement this one too so that you will see the difference. Look at it. If I want to implement it exactly the way it is. Are you with me, everyone? I will first of all need the first AND gate. This my AND gate will be 3 inputs. Oh, take notes. 3 inputs. 3 inputs. Okay, just for this first one only. And each of them, we have an inverter attached to them.
Inverter.
You getting me?
Yes,
The second
sir.
one, we also have its own inverter. The third one, we have its own inverter. Then you draw it out. You draw the second AND gate again. 3 inputs too. You will also bring it out. Then you go on and on. So you first of all use how many AND gates? 5 AND gates. When you are done with that, you will now look for a 5 input OR gate, which you may not easily get. Are you getting me now? For you to be able to what? To implement the circuit. You can see that will be very complicated. Do you understand? So that is the advantage you have if you are working with a Karnaugh map. It simplifies the circuit and give you an optimized circuit. So that is what you actually have here. What we have done is what you're actually seeing me showing a graphical way on the screen now. We have already done it. So we have C bar and AB bar. Okay, that's basically what we have. And then I've implemented the circuit. Now, there is a software that you will need to also use, an online tool. Okay, it's called Visual Paradigm. Okay, so it's the one I've used to just draw this circuit, and you can see it's looking beautiful. This is the link, online.visual-paradigm.com. So if you go there, you can draw circuit diagram looking beautiful like this one. I've just sketched for you and label it because it's part of what you would need to use for your assignment. So it's very important that you are able to lay your hand on this software. Okay? And I think that is all. We've been able to achieve at least the first 2 objectives of this class. Our time is fast spent, and we'll have a short test very briefly. And then
To be submitted when, sir? The assignment.
To be submitted, look at the date on the screen.
Oh, 29th, Friday, okay.
Good. Now, you can see what I've asked you to do. You have been given this Boolean expression, okay?
Okay.
Use K-map to simplify the function, okay? And I'm asking you, draw the simplified circuit diagram, okay? And I'm saying also use what? This software or any software of your choice to draw the circuit diagram, okay? Now, this assignment will be handwritten. Lord, pay attention to me. This assignment is to be handwritten, okay?
Okay, sir.
Solve it with your hand. Is that okay? And
yes, sir.
Detail, it's handwritten. You are also going to draw the circuit diagram. Are you getting me? So the circuit diagram you are drawing, you can save it as JPEG. And that doesn't stop you from drawing the circuit with your hand. You are still using the software to draw it. I will create a Google form to collect the circuit diagram that you draw from you. Okay? I will create a form to collect that from you when I'm ready to collect it. Okay? Then this question number 2. This particular one, you were giving the function this way. Okay? I believe you don't have any issue with the way you are giving. And in this case, I want you to draw this function the way it is, like I explained. Just, are we together, please? Hello? Are we together? So,
Yes, sir.
you draw the circuit diagram manually in your answer script, and then you also use the software to do the same. Then use K-map to also simplify and draw the simplified circuit diagram. And so that is all about the assignment. So I think at this point I can take questions. If you have any question, you can just ask your question now. And if there are no questions, we can go to have my tests. So if you have questions, let me know. Questions or comments? Okay, so in the absence of question, yes. If you're asking
can
your question,
come again?
Again, over which one now?
Where we have the empty key, the row and column reading from the table with C complement AB.
Talking about this?
No, sir. No, sir.
Okay.
Can still go
So
back, sir.
Where do you have concern?
Where we have the vertical and horizontal row being circled.
Okay, look at it. Just look at it. We have talked about 0, 0, 0. In this case, sir. AB is 0, 0. Okay?
Yes, sir.
Look at it. For the very first one now, we have AB.
Yes, sir.
0, 0, 0 we have here. And C, we also have 0.
Yes, sir.
And that place, we'll put 1 there because we have 0, 0 in the AB here. We have 0 in C here. So we simply put 1. Is that okay?
Okay.
Look at the next one.
Yes, sir.
We have AB is equal to what? 0, 1, which is,
1.
Look at A, 0, B, 1, 0, 1, AB, 0, 1. This AB, 0, 1, right? And then C, 0, C, 0,
AB.
Put 1 here. Are you following? Are you following?
Yes,
Yes,
sir.
sir. Yes.
Then
Yes, sir.
next one is 4, which is this. We have 1, 0, 0. So where do we have 1, 0? Here we have 1, 0 here. Okay? 1, 0. Yes. Then C, we have 0. So meaning we have 1 in this place. Okay? Next, we have 5, which is 1, 0, 1. Okay? 1, 0, 1. So we have 1, 0 here, and in the C, we have 1. And then we put 1 there. Lastly, you have 1, 1, 0. So we have 1, 1 here, and 0 is coming to me there, and so we put 1 in this place.
1.
Any other question again?
No, sir.
Okay. So in the absence of any other question, I want to say a very good evening to you. And before you go, I have a test for you. And the test is coming on this Zoom link as, okay, keep the annotation. Okay. Now, the test is coming on this platform. Okay? The test is coming as your test is coming on this platform as a quiz. Okay? You have just 3 simple questions, and it will simply require you to just put an answer. I'm giving you just 3 minutes for that also, just 3 minutes. Okay? So the question will come up now, and then you have just 3 minutes to respond to the question. So I wish you all the best. And those who have chosen not to mind whatever is happening, if at the end of the semester they didn't get what they bargained for, at that point in time, it will not be anybody's fault too. Okay? So just go ahead. I believe you can see it.
No, sir.
Can you see it?
No, sir.
No, sir. The poll is up. I've launched the poll. So click poll if you are not seeing it. It's supposed to pop up for you. The poll is up. It's coming as a poll. Can you see it?
No, it's showing pool in progress.
Click it now to respond. Click on the poll to respond. It's a poll. Can you access it now? Click to access the poll so that you can choose your answers.
The phone on the work.
Is it working now?
No, sir.
Click poll on your system. Oh, sorry, on your Zoom link. You have not used poll in Zoom before. Eh? Is it working for all of you now?
No, sir.
It is well with you guys, oh. Okay, let me project this QR code. You can just scan the QR code. Maybe that can help you. But ideally, you should be able to see the poll. Now, some people are already doing it now. What are you talking about? Some are already doing it. So if you're having any difficulty, try to look through your system. But meanwhile, you can also access it through this QR code I'm sharing on the screen. Is that okay? So you can screenshot the QR code that I've just projected now. Is that okay? So I think I've tried to. A lot of people are responding already. So,
Sir,
Sir, how are you going to know our matric numbers?
you don't worry now. The device you used to
I've
log in.
submitted though. Sir, I've
The
submitted
device-
though.
Hello.
Sir?
Hope you log in with your device name. So that's the name I will see. So if you log in with it, not your, it is not a good name. So you can quickly remove yourself.
So you log in with device name.
So check the name that is appearing in your Zoom meeting. Okay. So the name that you have, that's the name I will use to trace you. So if you know you are using
Submitted though. Sir,
Like,
submitted.
different.
somebody is calling himself Dean. Now we're going to award this mark to the dean of the faculty. So that person that calling himself Dean. Hello.
My name is Dean. My name is Dean.
Your name is Dean. Okay, but you don't have a full name.
Camera,
No problem. I'll be able to trace your name if your name is Dean. I'm
Sir.
seeing somebody. Yeah, speak. I'm hearing you.
What about those that had another name at the beginning of the class but changed it after submitting? Will it reflect our new names?
When you are changing it now, put the whole name there. I can use it to trace you. Is that okay? In brackets now, put the whole name that you have for your device.
Sir.
Okay, sir.
Yes.
Sir, as my own is showing divine answer, is my name used to know, right?
Young man, your name was showing divine. That's the name I will see there.
Okay, sir.
Okay. I'm seeing somebody else see divine something. And please, going forward, when you are joining this kind of meeting, ensure you use proper name. Okay? The essence of joining an online meeting is for you to have an identity. I'm seeing somebody Zoom user. That will not, if you're attending just a social function, you can use any name. But when you're attending an academic event like this, use proper name that can identify you. Okay? That's the best way to go. And the number is suddenly increasing though. I have 36 now.
Okay, so I just did that now.
Okay. So if you are renaming yourself, ensure you indicate the old name. Okay?
Yeah,
So that I'll be
I
able
just
to
did
track
that.
it when I'm harvesting the score.
Okay, sir.
It's all right.
Yeah. Sir.
Good evening, sir.
Yeah.
Sir, we have submitted, but how do we know if we have submitted? How do we check?
You don't need to know. Once you have done it, even if you didn't submit, the poll will automatically capture whatever you have done. That is why it's poll. You don't need to submit anything. Once I close the poll, whatever you have done is automatically submitted. So you don't need to worry yourself about it. Okay?
Sir, is this a joint class of 200 and 300 level?
Okay, I think I want to end the meeting. And it's funny that, okay? Yes, I'm hearing you.
Is the meeting for 200 and 300 level?
Asking that question. What
This is
level
my
are
first
you?
time. I'm in 300 level.
Which course?
Computer science, sir.
Which course are you attending? Which course are you doing now?
Sir, this is my first time. This is my first time.
You know, the question you are asking me is a very, it's not the best question. Because if you don't know the class you are attending, class you are attending, that speaks volume.
Dr. Laika, sir. Sir.
Who is speaking? Who is speaking?
Professor Laika, sir.
I'm hearing you.
Sir, our lab tech link you sent to us, we that have registered, how are you going to accept us, sir?
When did you register? When did you register? When did you register? Answer me now. When did you register? When did you register? That student cannot talk again. I said, when did you register?
Today, sir.
So, you think it's your matter that we're pursuing all the time? We have been on this matter for the past 3 to 4 weeks. Are you getting it? You are doing it today. And you want me to suspend every other thing to be attending to you. And earlier today, I even approved some people, meaning you just did it as this meeting is going on. I should pause this lecture and approve it for you. Please don't talk. I try to check the system. So because I receive an email whenever anybody registers. So, and I follow up. Even on my phone, I can approve. So just learn to do the right thing at the right time. It will help you. Not that you, because this way you're saying now, you're just exposing yourself to your colleagues. You have not been following. If you're just doing it now.
I follow the lecture, sir.
And your own is even better. Because as of now, we still have less than probably half of the class there. And you know what? You guys already know my method. There is going to be a test on that lab exchange in the next couple of days. It could be before this week runs out. You understand it now? And the test will wait for you there. If you like, do it. If you like, don't do it. Then when I collect my CA at the end of the semester, you yourself, you will know that of a truth, you have not really done the best for yourself. So you can advise your friends. You understand it now? All these scores, they are easy for me to collect. They are electronic. So if I have 1 mark here, 2 marks here, 3 marks here, I sum it up together, it gives me 30. So, and tell them they should not wait until they will say it's time for tests. I may choose not to do any test during your general test. Okay? It is continuous assessment, and I began to assess you continuously. Is that okay? So please advise your colleagues. It will not be the usual way some of your lecturers have been handling you, that you can be very unserious throughout the semester. You will just come towards the exam, do the test, get 20/30, and then they go and cram for the exam and do it and get maybe 40 or whatever, and you pass the course. This may not flow. Is that okay? So be part of the process and try as much as possible to be able to follow through, and that will be good for everybody. I'm interested in your success, and I want you to actually succeed. Okay? So I want to share the result of the poll with you. So let's do a quick review. Can you see the results? Can you see the result of the poll?
No, sir.
Everybody? You can see it, right? Are you seeing it, everybody? Yes. So what is the correct answer for question 1?
So we can't see it.
Both A and C.
I'm sharing it already. Can anybody see it?
Yes.
Yes, sir.
So, beautiful. So what is the correct answer? What's the correct answer?
A and C.
D.
A and C. That is option D.
That's D.
Okay.
Yes.
Some people choose. Some people choose A. Are we together, everyone?
No.
Yes, sir.
So
We
you
can
can
hear
see
you, sir.
you can see how some of you responded. 10 persons chose A, 6 persons chose B, 1 person chose C. That one person to simplify circuit components. And then 19 persons chose both A and C. So 3% of the class. That's that part, right? Let's look at the next one. How many cells are there in the 3 variable K-map? Some people still chose 4. Most people were not listening in class. Some people chose 16, 2 of them. Nobody chose 32. At least 89% got it right in this case. And lastly, what does a group of 1 cell in a K-map represent? Okay. 5 persons said a product term. And then 27 said a minterm. And then what? A literal, nobody. Variable. So what's the correct answer, if I may ask?
Minterm.
Minterm, okay? That's what we're playing with, okay? So 75% got it right. So pay attention to every little detail we are doing. And in the process, you will agree with me that you are learning. You are learning, okay? So on that note, I want to say very pleasant and beautiful evening to you all. And I want to encourage you, please keep learning and be open to learning, okay? The world is waiting for you to display excellence, show that you have a stuff to offer, okay? I need you to be positive to learning and be open to learning. And now good Lord bless you, and do enjoy the rest of your night. Bye for now.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thanks, sir.